Hey guys, LearnMoreFast here. Okay, so basically, I'm kind of shaking on this concept, and it's a very simple concept to understand. And I found this amazing web page that I had to share with you guys. Okay, so this actually this web page is, if you want to visit it, is the same http // chemwiki.ucdavis.edu, etc., etc., etc. I'll see if I can post a link after this, but it basically covers ice tables, and this gives you a perfect breakdown, a simple explanation, and a very understandable example. Actually, excuse me. Let's make that examples. They give you different scenarios, which is perfect. So, first of all, when it comes to ice tables, I'll do a little bit of reading here. An ice table is like a very simple matrix used to simplify the calculations in a reversible equilibrium reaction, usually of weak acids or weak bases. Basically what it does is it is composed of the concentrations of molecules in solution in different stages of a reaction and are usually used to calculate the equilibrium constant expression of a reaction. Okay, so basically it says K may be given. One or more of the concentrations in the table will be unknown, so you definitely need to know how to do this because more than likely she's going to give this on the exam. Ice tables automatically set up and organize the variables and constants needed when calculating the unknown. Okay, so we're just going to go through this quickly. It won't be too much. You need to know what ICE stands for. It's an acronym. It's not you don't really implement it in any way except for knowing exactly what each one means. So I stands for initial concentration, how it starts out. C stands for change in concentration. Concentration, basically the basic concentration change from the start to actually the difference of the final concentration when it's at equilibrium. And it says here it's expressed with either an appropriate positive or negative sign because this row represents change up or down, or sometimes no change. E is for the concentration when the reaction is at equilibrium. So this is the summation of the initial and change rows. So this is also important. Again, it says if you're looking for Kc, as you often will be at this stage of chemistry, this is the goal. Once you have the values in this row, you can easily obtain, and it's basically what this stands for, from what it looks like, is your actually change in your equilibrium constant concentration. So, and what you're going to do is you're going to be plugging them into the equation for your change in your equilibrium constant. And here's your few examples. Look at this. This is amazing. Okay, so example 1, using an ice table for amounts. Here's your equation that you're given, 2x in the gaseous state. You have your double-sided arrow, which means that the reaction can go in both directions. You have 3y gaseous state plus 4z in your gaseous state. So again, where the capital letters represent the products and reactants, this equation will be placed horizontally above the table with each product and reactant having a separate column. Here's the information you need to know. A sample consisting of 0.500 moles of X is placed into a system with volume 0.75 liters. Okay, so here's the breakdown. It's a very quality breakdown. I suggest you actually go into this website and read it. It's amazing. At equilibrium, the amount of sample X is known to be 0.35 moles. Excuse me. Again, here's your breakdown. Your desired unknown, how to solve it. And check this out, it's beautiful. Okay, so it shows you how to plug it in. Remember, okay, let's see. Here you go. Finding your equilibrium constant expression, you always put your products here and your reactants here. So we'll look back here. Here's your reactant side. Here's your product side. There it is, plugged in. And notice that the 3, 4, and the 2 that I said in my video about order and kinetics, that exact same video with actually I think I labeled it chemistry final intro. That same video, you can see that we just use the coefficients. Remember, you can only use that up to 6, so that is exactly that's a perfect representation right there. You putting in the given amounts. Again, here's your reaction. You just basically put in 2x, your reactants here, products. So you just do it in exact order. Sometimes what we actually do is we'll actually put the arrows in here instead of putting into an actual grid. Put your arrows here, and then I think they use an addition. Yeah, and put the addition sign right here, and just leave the equation as it is, and just write it out under. But this is perfectly fine. This is actually very beautiful. Again, here's your ice initial amounts, change in amount, equilibrium, ice, beautiful. There is your initial amount given 0, 0. So because that's the only thing that's changed. So remember that these two will be a 0 amount. Then you're also given your equilibrium amount, which is given, as I said, let's see, right here. I'm sorry, right here and right here. And then all you do is you've got to solve for these values right here. So you start filling it in. Basically, what gives you this will give you this, etc. And you're going to do the exact same thing throughout, depending on if it's 3, 2, or 4, etc. And basically, you're using this as your coefficient, so you're going to be multiplying that value by that value by that value. And what I'll do is I might put up another video to explain that, because that might take a little too long, and I'll have to change documents. But maybe actually, let's see if it shows you here. This is pretty good though. So the change in amount of x can be found. Oh yeah, here you go. The change in amount of x can be found easily by using algebra. Equilibrium amount equals initial amount plus change in amount, and that's going down. And you'll see what I mean. So there's the equilibrium amount, initial amount, and there's your change in amount. So this plus this is equal to this. So if you're given this, you just do reverse algebra. That's all it is. So there's your change in amount. Beautiful. Put it perfectly. Then you can work all this out, etc., etc. Solve for, and then you just solve for equilibrium amounts. It's like a 3-step process. It's beautiful. There's your answer. Here's another example. I'm not going to spoil it. This actually gives you fewer, and then you just do a quick plug-in. You can base it off of just a couple variables. Here's your checklist. You can go through this to make sure you solve these perfectly. Some extra practice problems, and let's see. Oh, here's an outside link. That's nice. Okay, I haven't viewed this yet. Go ahead. You can try viewing this. I'll see if I can put it in our description. Oh, I want to show you the solutions. But there's practice problems. Check those out. I'm gonna take it for a spin, and we'll see how this goes. So, happy studying, and I'll see you guys soon. Bye.